Have you ever dreamed of seeing one of the most incredible shows in the entire night sky? I'm talking about the Aurora Borealis, the Northern Lights. It's something that feels, well, almost unreal the first time you see it. And you know the best part? You don't need a fancy telescope or anything. This is one of nature's most breathtaking sights, and it's for everyone. So let's get right into it.
Just try to picture this for a second. You're standing out under a huge, dark sky, and you look up, and there are these silent, glowing green waves just drifting above you. You see these curtains of light that shift and pulse, almost like they're alive. It's this quiet, cosmic dance happening right up there in our own atmosphere.
I mean, it absolutely feels like magic, but this beautiful display, it isn't magic at all. It's a completely natural event. So what exactly are we looking at when we see the aurora? To figure that out, we can actually start with its name, which holds the first big clue.
Yeah, let's just start with the basics here. The name Aurora Borealis isn't just some poetic phrase, it's actually super descriptive. Once you get what it means, the whole thing starts to make a lot more sense.
Okay, check this out. Aurora was the name of the Roman goddess of the dawn. And Borealis? That's just a fancy way of saying northern. So, when you put it together, Aurora Borealis literally means northern dawn. And that's such a perfect description, isn't it? It looks just like a glowing, moving dawn breaking in the middle of a dark night. So how does this northern dawn even happen? Well, the story behind it is pretty incredible. It's a journey that starts 93 million miles away from us at our very own star, the Sun. It really just boils down to these 4 steps. First, the Sun is always sending out this stream of charged particles, which we call the solar wind. Now, when that solar wind gets to Earth, our planet's magnetic field acts like a giant shield, and it funnels all those particles down toward the north and south poles. Then, those particles slam into the gases in our upper atmosphere like oxygen and nitrogen. That collision gets the gas atoms all excited, and to calm down, they have to release that extra energy as light. And that light right there, that's the aurora.
Okay, but why all the different colors? It all comes down to which gas is getting hit and how high up it is. That famous bright green that we all know and love, that comes from particles hitting oxygen molecules, about 60 to 150 miles up. If they hit oxygen way, way higher up, you might get to see a faint red. And those rarer, beautiful purples and blues, that's our solar particles interacting with nitrogen. So you can think of our atmosphere as the paint and the solar wind is the paintbrush.
All right, now for the really fun part. You get the science behind it, so how do you actually see it for yourself? This is going to be your practical guide to going on your very own aurora hunt. So to give yourself the best shot, you need to get inside what's called the aurora zone. It's basically this ring around the top of the globe, near the magnetic North Pole. This is where that funnel of solar particles is pointed. So you've got to think far north, places like Norway, Iceland, Finland, northern Canada, and Alaska. Being in those spots puts you right under the main event. But listen, even if you're in the perfect country, there's another huge factor: light pollution. You could have an amazing aurora happening right over your head, but if you're in or near a city, the city's glow will just wash it all out. The number one rule is simple: get as far away from artificial lights as you can. The darker your sky, the more spectacular the show will be. And of course, timing is absolutely critical. The best season is generally from September to March, just because the nights are so much longer and darker. And your best bet on any given night is usually between 10 p.m. and 2 a.m. But honestly, the most important factor of all? The weather. If it's cloudy, you're just not going to see a thing. It doesn't matter how strong the aurora is. You've got to have clear skies. That's a deal breaker. So how do you know if you have a good chance on any given night? Well, you don't have to guess. The most important tool for any aurora chaser is something called the KP index. It's basically the go-to way we measure the strength of the solar storm causing the lights. And the index is actually really easy to understand. It just runs on a scale from 0 to 9. A KP of 0 to 2 means things are pretty quiet. But if you see a forecast for a KP of 4 or 5, that's a great sign, especially if you're up in that aurora zone. And if it ever hits 7 or higher, whoa, that's a major storm, and the lights might be visible way, way farther south than they normally are. And the best part is, you can track this stuff in real time. There are some fantastic and free apps and websites that give you live KP index data, maps, and even send you an alert when things are getting active. My Aurora Forecast and Space Weather Live are 2 of the most popular. They really take all the guesswork out of it. Okay, you've planned the trip, you're checking the forecast. There's one last thing we really need to talk about, and it's a big one. We've got to manage expectations, because what you see in those amazing photos isn't always what you're going to see with your own eyes.
You know those incredible, super vibrant pictures online? Most of those are taken with long exposure photography. That just means the camera's shutter stays open for a few seconds and soaks up a ton of light. But our eyes don't work that way. To the naked eye, the colors are often much softer, more like a pale, almost ghostly green. And sometimes, a faint aurora might just look like a weirdly shaped glowing cloud at first.
But, and this is so important, don't be disappointed by that, because your eyes can capture something that a static photograph will never ever be able to show you, the magic of its movement.
And this, right here, gets to the heart of what the real experience is like. The aurora isn't just a painting in the sky. It flows, it ripples, it dances. Sometimes it's slow and graceful, and other times it's flickering like crazy across the sky. It's that constant, dynamic motion that makes it feel so profound and so alive.
Ultimately, seeing the northern lights is about so much more than just a pretty color. It's the whole experience. It's standing in the deep quiet of a cold, clear night and just looking up in total awe as the universe puts on a show right there above you. And as you're standing there watching, here's a final thought to chew on. Some people have actually reported hearing faint crackling or hissing sounds during really intense displays. And this incredible light show? It's not just an Earth thing. We've seen spectacular auroras on other planets that have magnetic fields, like Jupiter and Saturn. It's just a reminder that the amazing physics creating this show above you, well, they're truly universal. So what are you waiting for?